This paper introduces a novel approach to dynamic dialogue generation using large language models, focusing on what-if scenarios in conversational AI. The authors, Navapat Nananukul and Wichayaporn Wongkamjan, propose a framework that enables the generation of context-dependent dialogue responses, leveraging the capabilities of large language models. They highlight the limitations of traditional dialogue generation systems, which often rely on static response templates or simple machine learning models. In contrast, the proposed approach utilizes large language models, such as transformer-based architectures, to generate dynamic and context-aware dialogue responses. The authors define the problem of dynamic dialogue generation as a sequence-to-sequence task, where the input is a conversational context and the output is a generated response. They propose a novel architecture, dubbed what-if-net, which consists of three primary components: a context encoder, a response generator, and a discriminator. The context encoder is responsible for encoding the conversational context into a compact representation, using a transformer-based architecture. The response generator takes this encoded context as input and generates a response using a language model. The discriminator, also a language model, evaluates the generated response and provides feedback to the response generator. The authors employ a combination of supervised and reinforcement learning to train the what-if-net architecture. During training, the model is presented with a dataset of conversational contexts and corresponding responses. The response generator is trained to maximize the likelihood of generating a response that is coherent and context-dependent, while the discriminator is trained to distinguish between generated and human-written responses. The paper presents several key findings, including the effectiveness of the what-if-net architecture in generating dynamic and context-aware dialogue responses. The authors also demonstrate the importance of using large language models in dialogue generation, highlighting the benefits of leveraging pre-trained language models as a starting point for fine-tuning. The proposed approach has significant implications for conversational AI, enabling the development of more sophisticated and engaging dialogue systems. However, the authors also acknowledge several limitations, including the need for large amounts of training data and the potential for generated responses to be biased or uninformative. Future work directions include exploring the application of the what-if-net architecture to other conversational tasks, such as question answering and sentiment analysis. Additionally, the authors plan to investigate the use of multimodal inputs, such as images and audio, to further enhance the context awareness of the dialogue generation system. Maintaining continuous and contextually appropriate dialogue in role-playing games, RPGs, is a significant challenge, particularly in story-driven RPGs like Final Fantasy VII Remake, FFVIIR, and Pokémon. This challenge is addressed by integrating knowledge graphs with large language models, LLMs, to generate nuanced filler dialogues tailored to each character and game scenario. The inconsistency of dialogue, especially moments of unnatural silence, disrupts player immersion and diminishes the storytelling experience. Advanced AI capable of maintaining continuous, contextually appropriate dialogue can help address this challenge. The proposed framework combines game-specific knowledge graphs with LLMs to produce dialogues that are contextually rich and character-specific. In FFVIIR, the focus is on improving repetitive in-battle dialogue, which lacks variation and fails to adapt to the boss's changing states. Dynamic dialogue for main characters is generated in response to different battle states, enhancing the player experience. For Pokémon, the goal is to create dialogues for the main character, Red, who does not speak during gameplay. Red's character is enriched with various characteristics, such as being hot-headed or kind-hearted, depending on the situation. GPT-4, a large language model, is leveraged to generate dialogues where character profiles, NPC backgrounds, and scenarios are given. Knowledge-based data, such as knowledge graphs, is incorporated to enhance text generation quality. The process involves scraping data from online sources, creating triples for knowledge graph instances, and prompting GPT-4 with the knowledge triples and a specific scenario to generate dialogue. The integration of knowledge graphs and LLMs for dialogue generation is a key contribution of this paper, along with an evaluation of the capability of current LLMs technology. The proposed approach presents a novel solution to generating nuanced filler dialogues in RPGs, utilizing advanced AI and large language models to create a more engaging and authentic player experience. In this section, the authors present a novel approach to generating context-aware dialogue in video games using knowledge graphs and large language models. They utilize the Final Fantasy VII Remake, FFVIIR, and Pokémon as examples to demonstrate their methodology. The process begins with data collection, where character information is extracted from game wiki pages and compiled into a knowledge graph, KG, using GPT-4 and predefined ontology concepts and relations. This KG stores information about non-player characters, NPCs, their personalities, abilities, relationships, and events they influence or participate in. Additionally, the authors gather comprehensive data on boss battles, including skills, weaknesses, and various states. The authors then construct small knowledge graphs tailored to FFVIIR and Pokémon, which are designed to store and organize information about NPCs and their associated Pokémon. These knowledge graphs are represented as triples, structured as subject-predicate-object, that describe relationships and attributes of NPCs and Pokémon within the game's universe. The authors demonstrate the conversion of descriptive text about a character, Sabrina, into RDF triples, showcasing the methodology for semantic representation of character information. Key attributes such as gender, outfit, height, and associated Pokémon are extracted and formatted as triples. The authors then discuss prompting methods for generating dialogue in FFVIIR. They provide GPT-4 with knowledge triples, character triples, boss triples, and a specific situation in a battle to generate dialogue that responds to specific scenarios. The instruction guides GPT-4 to use the given knowledge about characters and bosses. For example, when Barret is low on health and the Scorpion Sentinel is about to use Electrostomp, Cloud can respond with a cold but tactical remark. The authors aim to utilize these knowledge graphs to generate context-aware dialogue that enhances player immersion. By integrating these triples into a knowledge graph, they can utilize these triples in LLMs to generate context-aware dialogues based on the NPC's distinct personalities, appearances, and relationships with their Pokémon. The figures provided illustrate the process of data collection, knowledge graph construction, and dialogue generation. Figure 2 shows an example of the method using FFVIIR, while Figure 3 demonstrates the conversion of descriptive text about Sabrina into RDF triples. Figure 4 is not provided, but it is mentioned as an example of Cloud's response to a specific situation in a battle. Overall, this section of the paper presents a novel approach to generating context-aware dialogue in video games using knowledge graphs and large language models. The authors demonstrate the effectiveness of their methodology using FFVIIR and Pokémon as examples, and highlight the potential for enhancing player immersion through context-aware dialogue. Researchers have investigated the application of GPT-4 in generating context-aware dialogue for video games, focusing on characters Cloud Strife from Final Fantasy VII Remake and Red from Pokémon. By prompting GPT-4 with character personalities, abilities, and battle information, the model can produce dialogue that reflects their traits and situations. For instance, prompts can be designed to generate dialogue for Cloud facing the Scorpion Sentinel boss or Red interacting with gym leader Sabrina. The authors emphasize the importance of incorporating knowledge graph data to inform these prompts, ensuring contextually relevant generated dialogue. Preliminary results indicate that GPT-4 tends to generate positive responses, even when a character's personality might suggest otherwise. This could be attributed to the model's tendency to generalize positive traits. To obtain quantitative data on the effectiveness of GPT-4 in generating context-aware dialogue, the authors plan to conduct human evaluations. This research explores the potential of large language models like GPT-4 in enhancing the dialogue generation process in video games. By leveraging these models, interactions between characters can become more engaging and contextually relevant. The study highlights the importance of considering character personalities, abilities, and situational context in generating dialogue that accurately reflects their traits. The use of knowledge graph data is crucial in informing prompts and ensuring contextually relevant generated dialogue. The author's approach demonstrates the potential of GPT-4 in generating context-aware dialogue, paving the way for more realistic and immersive gaming experiences. Future work will focus on refining the model's ability to generate more nuanced and context-dependent dialogue. Researchers fine-tuned GPT-4 to align with the personality of Cloud, a character from Final Fantasy VII, and instructed it to focus on Cloud's abilities and Boss's weaknesses. However, results showed that while some responses leveraged knowledge of Boss's skills and weaknesses, most were based on situational context. To further investigate, the researchers conducted an experiment using the Pokémon game context, where they endowed the main character Red with 5 distinct personalities: mature Pokémon trainer, amateur Pokémon trainer, talkative, timid, and confident. Using GPT-4, they generated 120 dialogues for Red, synthesizing responses based on the specified personalities. A human evaluation was conducted, where evaluators rated Red's responses based on how well they expressed Red's personality and how reasonable they were in conversation with a gym leader. Results showed that GPT-4 generated personality-based dialogue, with significant differences in dialogue generation based on the specified personalities. The quality of GPT-4's responses was high, with over 50 out of 120 responses rated 4.55.0. GPT-4 effectively incorporated specific information from the knowledge graph, such as mentioning specific Pokémon in its responses. Notably, GPT-4 excelled at personating a talkative Red, retrieving the highest score for both tasks when Red was talkative. The experiment demonstrated GPT-4's ability to generate distinctly varied dialogue that aligns with predefined personality profiles. The results highlighted GPT-4's ability to adapt its responses based on the personality trait assigned to Red and incorporate specific information from the knowledge graph. The researchers used a prompting method tailored for the Pokémon game context, allowing them to explore the impact of personality on dialogue dynamics. The human evaluation used a slider-based rating system, where evaluators rated Red's responses based on how well they expressed Red's personality and reasonableness in conversation with a gym leader. The results are presented in Figures 69, showing the human evaluation tasks and ratings for Red's responses. Table 2 demonstrates GPT-4's ability to generate personality-based dialogue that aligns with predefined personality profiles. In the research paper, the authors showcase GPT-4's ability to generate dialogue for Cloud Strife in various boss battles from Final Fantasy VII Remake. They present interactions with Scorpion Sentinel, Reno, and Sephiroth, each featuring 5 sampled responses with the best one selected for illustration. The provided table highlights how Cloud's responses adapt to different situations, such as advising Barret to pull back when his health is low and to keep the enemy's attention when his health is normal during the Scorpion Sentinel battle. Against Sephiroth, Cloud criticizes relying too much on M-mines as a bad call for Reno. The authors also discuss future work, aiming to expand their study to other video game series and conduct more human evaluations, including for Final Fantasy VII Remake. They intend to explore how well GPT-4 can act as a game character and provide responses that are unexpected yet fitting. Histograms in Figure 8 illustrate the distribution of ratings for how well Red's responses reflect his personality and conversation fitness. The analysis shows that straightforward personalities such as talkative, timid, and confident are trivial for GPT-4 to derive, while those with unclear personalities, like being mature, might be challenging for GPT-4 to clearly express in words. A bar chart in Figure 9 displays the average ratings based on each personality type, with blue bars representing the average personality ratings and lime bars representing the average conversation fitness ratings. This further emphasizes the effectiveness of GPT-4 in generating dialogue that reflects the character's personality and conversational fitness. In the realm of text-based games, enhancing dialogue generation is a pivotal step towards creating more immersive experiences. The authors propose leveraging large language models, LLMs, and integrating knowledge graphs, KGs, to achieve this goal. They illustrate their point with an example from Pokémon Red version, showcasing 5 distinct responses from the main character Red, each reflecting different personality traits. The effectiveness of GPT-4 in maintaining character consistency and utilizing knowledge in its responses is evaluated. The paper also reviews related works on dialogue and text generation in games, highlighting studies that employed Word2Vec embeddings and BERT to introduce inference capabilities and produce contextually relevant dialogue. Moreover, it discusses the role of knowledge graphs in enhancing dialogue generation across various domains, including medicine, question-answering systems, and gaming. By integrating LLMs and KGs, the authors suggest that dialogue generation in text-based games can be significantly improved, leading to more engaging and immersive gaming experiences. This study investigates the capacity of GPT-4 to accurately emulate game characters and provide responses that align with their personalities and situational contexts. Focusing on the main characters of Final Fantasy VII and Pokémon, the researchers examine how well GPT-4 maintains character consistency and utilizes in-game knowledge when generating dialogue. Building upon previous research that employed large language models, LLMs, to enhance and innovate text-based games, this study contributes to the growing body of work on LLMs in gaming. The researchers' qualitative analysis reveals that GPT-4 can maintain a high degree of character consistency. Furthermore, the task of highlighting knowledge-based and situational responses provides insights into the model's ability to integrate specific game details into its responses. The study's findings highlight the transformative potential of LLMs in redefining gaming experiences by providing rich, adaptive, and personalized content. The researchers propose future steps, including refining the model through supervised fine-tuning to better align GPT-4's responses with the main character's personality traits. They also aim to extend their evaluation methods to human evaluation and apply it to other characters and dialogue generation tasks within various game contexts. The study demonstrates the potential of GPT-4 in enhancing character-driven interactions in gaming, paving the way for more sophisticated and engaging LLMs-driven dialogue systems. The study's methodology involves fine-tuning GPT-4 on a dataset of game dialogue to enable it to generate responses consistent with the characters' personalities and situational contexts. The researchers discuss the limitations of their approach, including the need for further refinement of the model to better align its responses with the character's personality traits. The study's contributions include the demonstration of GPT-4's capacity to accurately emulate game characters and provide responses that align with their personalities and situational contexts. The researchers also propose a novel approach to evaluating the performance of LLMs in generating dialogue that is consistent with the characters' personalities and situational contexts. The study's implications are significant, highlighting the potential of LLMs in redefining gaming experiences by providing rich, adaptive, and personalized content. The researchers' approach has the potential to be applied to a wide range of games, enabling the creation of more sophisticated and engaging dialogue systems. The paper introduces a novel benchmarking tool for dialogue generation, DikeChat, which emphasizes grounding dialogue on dynamic knowledge graphs. This advancement is crucial in the field of natural language processing and artificial intelligence, as it evaluates the ability of dialogue systems to incorporate and utilize external knowledge effectively. DikeChat assesses how well a dialogue model can generate responses that are contextually relevant and factually accurate, leveraging information from a dynamic knowledge graph. The authors, Yilin Tuan, Yun-Nung Chen, and Hunji Li, have made their work available through an archive preprint. In addition to DikeChat, the paper also presents a comprehensive analysis of existing dialogue generation models, highlighting their limitations and potential improvements. This research contributes significantly to the development of more sophisticated and knowledgeable dialogue systems, paving the way for future advancements in human-computer interaction and conversational AI.